Hello everyone, I'm Namratha Menon. I would like to discuss about my project topic, Safe Walk Robot. Let us now look into some statistics to understand the importance of this project topic. As per FBI's National Crime Information Center statistics for the year 2016, it shows an increase in number of violent crimes, and it is reported that there has been a 4.1% increase compared to the year of 2015 in 2016. Cases such as murder, non-negligent manslaughter, rape, robbery, burglary, aggravated assault, and more come into this category of violent crimes. Out of it, murder and non-negligent manslaughter shows an 8.6% increase. Reports also says that there are as many as 90,000 missing persons in the United States. So the technology now is advancing as to employ robocops and robo-soldiers to lower this increasing crime counts. So my concept was to introduce a robot which can safeguard a person who is walking alone. To lower this increasing crime counts, a suggested method is to employ a system which can do real-time monitoring and thus provide a positive impact on the crime numbers. The system proposed should have the following abilities. It should be able to see and hear everything, communicate this gathered information to the central processing unit for analysis. If the system is supposed to assist pedestrians, the surveillance system should be able to follow the person. The objective of my project topic is to develop a system which will be an aid for a person walking alone, and it will be helpful if he is under a threat to life by a human. So the functionalities of the system should be, it should follow the user till the desired destination and to detect the presence of the perpetrator and alert the user. This shows the block diagram view of our prototype system. The main processing unit is a Raspberry Pi. It receives inputs from ultrasonic sensors and camera. Ultrasonic sensors are used to guide the rover behind the user. Camera is used to monitor the surrounding environment of the user, and L29 3D and motor support to guide the rover behind the user. Once the perpetrator presence is detected in frames selected, Raspberry Pi then sends an alert message to the user's mobile phone. Here I have shown the schematic diagram of our prototype system. There are three ultrasonic sensors which are interfaced to the general purpose I/O pins of the Raspberry Pi, and according to the values obtained from the ultrasonic sensors, control signals are generated by Raspberry Pi and then sent to the motors to control the direction and speed of the motor. As the output from the Raspberry Pi GPIO is 3.3 volts and this is not sufficient to drive motors, I have used a motor driver IC, and the control signals from the Raspberry Pi is sent out to this motor driver IC, and further that controls the DC motors. Now let's look at the components used to develop the prototype system. First of all, Raspberry Pi. This system could be implemented with any programmable logic board having image processing capabilities. The reasons behind selecting Raspberry Pi as our processing unit is it has 40 GPIO pins, provides interfacing convenience, has 1 GB RAM, image processing capabilities, wireless LAN and Bluetooth on board, provides 4 USB ports, and compared to the older versions of Raspberry Pi, Pi 3 model provides faster computing abilities And as it can be conceived as a complete working computer, we don't need any additional hardware to alert the user about the perpetrator. Ultrasonic sensor HCSR04. This module includes transmitter, receiver, and a control circuit. The transmitter sends out 40 kHz ultrasonic signals, and the receiver waits for the reception of the echo signal. The difference between the transmitter and the received signals is used to calculate the distance between the obstacle and the sensor. The distance is calculated by using high-level time times the velocity of sound over 2. This device provides the distance to the obstacle within a range of 2 to 400 centimeters. You can also achieve ranging accuracy of up to 3 mm. In this project, I have used 3 ultrasonic sensors to make the rover navigate behind the user. The robot navigates depending on the decision criteria satisfied according to the values obtained from the sensors. Raspberry Pi camera module. As we discussed, Raspberry Pi provides a camera port for connecting camera module. To have a better resolution, I have used 8 megapixel 1080p camera module, and the flex cable connector is used to establish the connection to the camera port. The camera module is used to monitor the surroundings of the user. Video captured by the camera is processed inside the Raspberry Pi, and any human presence in the image is detected. User is alerted in case of human detection in the image. Let's discuss the algorithm for navigation of the rover behind the user. The directional speed of the motion of rover is determined by the values obtained from the 3 ultrasonic sensors. I have placed sensors such that one receives the center value, one from left, other one from right. Depending on which sensor gives the least distance to the user, the direction of the rover motion is changed. I have also provided a preset minimum distance value between the user and the rover. The system has to pass through the user authentication to make sure that it is not following anyone else. Coming to the flowchart, it first checks whether the distance information obtained is within the range that our sensors can calculate. If not, it loops back and stays in the same state. Once it comes to the range of the sensor distance, it checks whether it satisfies the preset minimum distance. Again, if not, stays in the same position by issuing stop commands. If not, it will check whether the middle sensor is giving the least value or not. If it is not giving the least value, then we can say that either the left or the right the user is moving. Then checks whether left or right sensor, whichever gives the least value. Depending on which one gives the least value, if the left sensor is giving the least value, moves to the left and then follows to the control flow again. If not, moves to right and loops back. Image processing for human detection. I have used OpenCV library support to perform face detection from the collected frames. OpenCV refers to open source computer vision library which has C++, C, Python, Java interfaces, and Windows, Linux, Mac, Android platform supports. It is designed for computational efficiency for real-time applications and take advantage of heterogeneous computing platform for hardware acceleration. Here I have used the machine learning approach of training the cascade function using positive as well as negative images, which is further used to detect the face. For training face, 2 sets of images are created, where one with faces, which is the positive set, and one without, which is the negative set. The next step is the extraction of features. The HAR features such as edge features, line features, rectangle features are used, and feature is represented as a single value which corresponds to the difference of sum of pixels of white and dark rectangles. The best features are selected and each feature applied on training data, and those features with minimum error rate are selected. Rather than applying all the features, we are using cascade classifier here, wherein we'll be applying the features which are selected and applying it as different stages one by one. If it fails in first stage itself, we don't need to consider that image at all. If it doesn't, and if it passes through all the stages successfully, then we have successfully got a phase. Implementation of SafeWalk robot. The rover is set up with 3 ultrasonic sensors facing the rear of the user. The sensors are interfaced with the Raspberry Pi, and according to the algorithm discussed for the navigation of the rover follows the user. The camera module is interfaced to the Raspberry Pi's cam port. The data collected by the camera is processed to evaluate the presence of the perpetrator as per the face detection software. Upon detection of human face in the video, user is alerted to email. The problems faced while designing the SafeWalk robot were: while powering the Raspberry Pi and the motor, if I was using the same source, it resulted in a poor movement of rover. The reason was that the motors were not getting enough current to drive. And to overcome this issue, separate power sources were used. Thus, this concept of SafeWalk robot was successfully implemented, and the system designed will act as an aid for people who are walking alone and under threat to life by a human. The information collected about the perpetrator would be helpful for future crime investigation, and the system as a whole can act as a personal safeguard.